In this case, because NO3 minus is the conjugate base of a strong acid. Okay, so now I'm going to continue through quite a few of these salts. There's 7 in total, but we can't see all of them here, but I'll preface by saying what the salt is in each case. And instead of using the 1, 2, 3 numbers, I'm just going to use A, so I don't get myself confused. Okay, so the first one is NH4Br. This is going to completely dissociate into NH4 plus Br minus. NH4 plus is an acid, or it's a weak enough acid that we're going to get H3O plus. Br minus, if we try to write an equilibrium expression, is going to be HBr plus OH minus. But HBr is a strong acid, so this is wrong. And this only goes in that direction. And so because this reaction doesn't occur, then the solution is acidic. Okay? Yeah. So this salt is an acidic salt. And now we can start to see a little bit of what the rules are here. So this salt is formed from a weak base, right? So NH3 would have been the base and a strong acid. So HBr would have been the acid. And so it's a weak base with a strong acid, and so the solution is acidic. Okay? So that would have been its original formation. I find it easier to just look at exactly what's going to be in the solution and work it out that way, but it's up to you. You can memorize some of these rules. Okay, so for B, we have strontium Br2 strontium bromide. So we would completely dissociate into Sr plus Br minus, 2 of them. Sr plus is going to presumably react with water to give us SrOH minus plus, what's the best way for me to write this actually? How did I write this here? Plus H plus, I guess. That one's a funny one. Yeah. Okay. And then Br minus plus H2O is going to give us HBr plus, that wouldn't be minus, plus OH minus, like that. So I suppose, so that would be the acid and the base in this case, but if we look, right, this here is a strong base, and this here is a strong acid, meaning that these don't occur because they're both going to want to just go this way, and so neither of these reactions are actually going to happen, and so the whole thing's going to be neutral, because in the end all we're going to have is the strontium. We're just going to have the reactant side here. And so if that's in solution, then that's neutral. Okay. So here we have KCN, which is going to completely dissociate to give us our K plus Cn minus. K plus is also just going to give us our KOH, and Cn minus is going to give us HCN plus OH minus. Now, so as before, this is a strong base, and so this reaction doesn't occur. It actually just goes this way. And so the only reaction that's going to occur is this one, which gives us OH minus in solution. So this is going to be basic. And so we've got, so this is from a strong base. This is from a weak acid. And so the salt is basic. In the question before, I didn't mention it, but they were both from strong acid and strong base, so it comes out to be neutral. So the fourth one here, D, is LiF, which is going to completely dissociate into Li plus F minus. Our reactions here now are going to be LiOH plus H plus F minus. It's going to be HF plus OH minus. Now this here is a strong base, and so it might start to become obvious. But basically all the alkali or alkaline earth metals with OH are always strong bases because they will completely dissociate in solution. And so that doesn't happen. It just goes this way. HF is our only hydrogen halide that is a weak acid. So this reaction does occur. And so the salt will be basic. And so again, we have this is from a strong base, which is LiOH. This is from a weak acid, which is HF. So this salt is formed from a weak acid and a strong base, so it's basic. Or we can just write out the chemical equations. So the fifth one here, which I'm calling E, is NH4Cn. Now this is going to give us NH4 plus Cn minus. So in solution we have NH4 plus H2O, giving us NH3 plus H3O plus, Cn minus plus H2O, giving us HCN plus OH minus. So now in this case, we both have a weak acid and a weak base, so we can't make these assumptions that we made above. But depending on which direction you want to see it as, but basically looking at the backwards direction is sometimes easier, but HCN is a weaker acid versus NH4 plus. Okay. So if HCN is a weaker acid than NH4 plus, then that means that CN minus is a stronger base. Then NH4 plus is an acid. Okay, so stronger base than NH4 plus is an acid, and so then the whole thing will be basic. Now, just to add a little bit to that, right? So remember that our KB is always related to our KW over our KA, where this is a constant, right? That's the water constant, so 1 times 10 to the minus 14. Ka corresponds to the conjugate acid, so HCN, and Kb corresponds to Cn minus in this case. So that means if HCN is weaker than NH4 plus, then this value is very small. If you divide by a small number, then you get a larger number on the other side. So if HCN is a weaker acid than NH4 plus, it means that Cn minus is a stronger base than NH4 plus is an acid, and therefore the solution will be basic. Okay, so I hope that makes sense. Okay, now moving on-ish. So the sixth one, which I'm labeling F, NH4 ClO4 is going to completely dissociate into NH4 plus ClO4 minus. So we've got NH4 plus H2O giving us NH3 plus H3O plus ClO4 minus plus H2O goes to HClO4 plus H2O. Sorry, not H2O, OH minus. Okay, so again, neither of these are strong acids or strong bases, so we can't make any judgments that way. But we can say that this species is a stronger acid than NH4 plus. Okay, so the reason we can say that is because although NH4 plus has a positive charge, this guy is bound to a large amount of electronegative atoms. So it's very likely that this bond in this molecule is very weak. And so this species is going to be a stronger acid than NH4 plus, meaning that this species is a weaker base than NH4 plus is an acid. Then NH4 plus is an acid, Okay, so that means if this is a weaker base, then this is an acid, then the whole solution will be acidic. So the whole solution is acidic. Okay, and I guess I should have written that somewhere. Oh, I did there, I guess. Okay. Okay. So it was very similar rationales to the previous question, right? Or to the previous salt, because it's just in competition between the acid and base, and as the acid is stronger, then the whole solution is acidic. Okay, and then the final salt is LiNO3, which completely dissociates into Li plus NO3 minus. Here we have Li plus H2O going to LiOH plus H plus, NO3 minus goes to HNO3 plus OH minus. And if we look, this is a strong base. And this is a strong acid. So this is nitric acid. So this is kind of one of the polyatomics that would be worth remembering. And so then neither of these occur. And so then the whole solution will be neutral. Okay. So there's, I ran through a bunch of them there. Hopefully it made some sense. So let's check through our solution here. So the first one is acidic, looks good. The second one is neutral because they're both strong acid, strong base. The third one will be basic. The fourth one will be basic. The fifth one, which was the competition between the two, is basic. The sixth one, which again is a competition. Oh, maybe not. Yeah. Oh, okay. So yeah, HClO4 is actually a strong acid. I knew it was a stronger acid, but it's actually just a strong acid. So that's my mistake. So apparently this doesn't occur at all. So that makes that rationale even easier. So that's going to be acidic. And then for the seventh one, it's just neither of them are going to occur, so it's just neutral. All right, sounds good. So that looks good.